you ever wondered how your desktop or laptop or smartphone or tablet just kind of connects to a network? You turn it on, something happens, and all of a sudden it just magically works. Well, it's not exactly magic. It works largely due to something called a DHCP server. DHCP stands for Dynamic Host Control Protocol, and a DHCP server is the thing that's responsible for giving your device an address that lets it communicate on a network. In this video, we're going to deploy a DHCP server in Windows Server 2022. Let's do it. Hey everybody, Troy here, and as I said in this video, we're going to be deploying a DHCP server in Windows Server 2022. As always, timestamps in the description below. Feel free to jump around if there's a specific section you want to get to, or just walk through the deployment with me step by step. All right, let's dive in. First thing we're going to do is take a look at our lab infrastructure. You can see I'm running a fairly simple environment to demo this for you today. I'm running 2 virtual machines connected with a Hyper-V private virtual switch. The first virtual machine is a server running Windows Server 2022. I'm going to deploy the DHCP role on there, and I'm going to deliver addresses to my client machine over here at PC01, which is running a copy of Windows 10 Professional. Now, I happen to be running Windows Server 2022. Don't worry if you're running 2019 or 2016. The steps are intrinsically the same. You'll be able to follow along with no problem. Now, I've also already assigned some static addressing in IPv4 and IPv6 to my server, and my Windows client will ultimately become DHCP assigned. So what we're going to do is use an address from the pool that we assign in our server to deliver an address to our client. Okay, let's do this. So I'm going to bring up my virtual machines. As I said, I've got a PC running. I'm going to set that aside for a second. I'm going to start with my DHCP server, which I've called DHCP01. To get this train rolling, one of the first things we're going to do is pop into our fine friend Server Manager, and we're going to use it to deploy our DHCP role. Now, couple prerequisites I recommend before you dive in. First thing I've done here is I have given my computer a sensible name, DHCP01. That's going to be the name of my server. I have not connected this with Active Directory. That is in videos to come. This is in a simple workgroup environment. And as I mentioned from the topology, I have assigned an IP address of 192.168.0.1. I've also assigned an IPv6 address. These are static assignments, which is best practice. Generally, our servers, we want to have a manually or statically assigned address so they don't just change on us all of a sudden in a production environment. All right, let's start with the installation of the server role. I'm going to move in my dashboard tab. I'm going to click on the option that says add roles and features, and into the wizard we go. I'm going to click next. This is a role-based installation, and you're going to see here that I've got a bit of a summary of the current server, DHCP01 192.168.0.1. Again, highly recommend, if you're not seeing what you expect here, exit the wizard, go back, check your configuration. It might save you a lot of pain and hassle later on. I'm going to select that as my server, and up come my role options. DHCP, that's what I'm after, and it immediately gives me a chance to add all the management features that I want, which of course I'm going to accept. Hit next, and away we go through the wizard. It warns me I should have at least one static IP address on this computer. Again, good practice. Make sure that your server isn't going to just arbitrarily change its IP address. I'm going to hit next, and it gives me a chance again, warning me if this were a production environment, it may have to restart after the installation of this role. DHCP does not require it, but if I wanted to check that box, I'd want to be very careful, because once the installation is done, the server is just going to reboot, and that could mess up a lot of things for you. I'm going to hit install, and installation on its way. Now, this isn't a particularly heavy installation. It's only going to take a moment. As you can see, I've got a progress bar. And as I'm doing this, I see there's another spot here that gives me a chance to export my configuration settings. Again, just like the DNS wizard that we saw in another video, I can export this file, which will maintain this configuration that will actually let me integrate this with PowerShell if I wanted to deploy DHCP as a server role via my PowerShell commandlet. There we go, succeeded on DHCP 01, and I'm going to hit close, and look at this. I've already got a new set of options right here. So DHCP is now a recognized role on the computer. Let's move to our DHCP tab and see what we have in store. As you can see, I've got a notification here saying that there's a bit more work to be done. We've installed the server role, but there is a post configuration requirement with respect to DHCP. I'm going to follow the wizard by clicking on the More option right over here, and it tells me there is a post-deployment configuration, post-deployment of the role. What I need to do is complete this DHCP configuration. I'm going to hit this, and what it's going to do is it's going to create a couple security groups that I need to manage DHCP. It's as simple as me acknowledging the creation of these groups. I'm going to hit the Commit button, and it will create these groups on my behalf. I'm going to hit Close, and we are done. Okay, so now that is finished, and you can see that as I move away, that little post configuration requirement is now gone. Now I can right click and I can move to my DHCP manager, or I can find that same manager underneath my tools drop down menu. DHCP, this is something we call an MMC, a Microsoft Management Console. We're simply gonna open her up and take a look. You can see on the left hand side I've got a little bit of a navigation tree that shows me 2 green check marks, says that I am ready to rock this role as a DHCP server for both IPv4 and IPv6. So now to make this server actually do something, we have to do some configurations. We have to actually create something called a DHCP scope. Now, what is a scope? Well, the scope is a fancy word for the address pool. And by address pool, I mean the pool of addresses that our server is going to hand out or lease to client devices that are requesting addresses. Now, before I configure the scope, there are some decisions that I often have to make. My particular computer is on an environment that's going to be handing out addresses for its local network. Now, that local network, let me bring up a little notepad here for you, is 192.168.0.0 with a /24 notation. That means it is a 255.255.255.0 subnet mask. Now, those of you who are comfortable with IPv4 addressing are quick to realize that this allows me a total of 256 possible addresses, of which 254 of those addresses are usable. That address range is 192.168.0.1, and it goes all the way up to 192.168.0.254. Those are the usable addresses, 1 through 254 and everything in the middle. Now I've got some options here. I could tell my DHCP server that you are free to hand out any address in this particular address range, and I could call that my scope. That's fairly easy. A couple things I got to be careful of though. Well, first off, my server is 192.168.0.1. I definitely don't want my DHCP server to hand out this address to another client. Well, I'd have a duplicate. I might also have other devices on this network that I have to be careful with. I might have other servers on this network. I'll probably have a router that is my default gateway. I might have switches. I might have UPSs. I might have all sorts of devices that I need to statically assign addresses for. So I've got a couple options. One thing I can do is share the entire scope and exclude specific addresses that I want to assign statically. Or what I typically do, I will break this down and only assign a portion of this address space as my DHCP scope. So for example, what I'm going to do is I'm going to give 192.168.0.50 through 192.168.0.100. Basically what I'm saying is that I want to assign the addresses from 50 up to 100, which are 51 addresses, and I'm going to use those to hand out to my clients. Again, that's a very small scope, so we typically wouldn't do that in production, but I wanted you to see the flexibility and the configuration ability that we have at our fingertips. But by doing this, it means that the DHCP server is not going to hand out addresses from 1 through .49, and it will not hand out addresses starting at 0101 all the way up to 254, which I might want to use those for something else. Excellent. Let's go and deploy this. What I'm going to do is right click on my IPv4 option, and you're going to see I get a chance for a new scope. Let's hit that button. Up comes a wizard. Next, gives me a chance to name this particular scope. I want it to be descriptive because my DHCP server can actually offer addresses to multiple different networks. It doesn't have to be just the network that I'm on. And so I want the description and name to let me delineate these from other scopes that I might be using the server for. But I'm only deploying a very simple one scope network, which I'll refer to this, maybe I'll call this my data LAN. And I hit next, and here I'm presented with the chance now to define that scope. Remember, in my notepad here, I isolated what I wanted to. Nothing wrong with me going for the complete address space if I wanted to. It just determines some different decisions later on. I said that for this lab environment, as an example, I'm simply going to hand out addresses between 50 and 100. Let's type that in, 192.168.0.50. There we go. And my end of this scope is going to be 0.100. All right. Now you can see that it's challenging me to confirm the CIDR notation or the slash notation here associated with this network. This is a /24, or the subnet mask is 255.255.255.0. Now the reason this is important is because this is part of the configuration that the DHCP server will hand out to its clients. It will hand out an address and it'll hand out an applicable subnet mask, and we need that mask to be correct so these client devices can participate in our network. Next again, let's look at a chance to add any exclusions. Now remember, what I said is if you had elected to deploy the entire address range, there may be addresses that you do not want your DHCP server to hand out. This is the chance I get to add an exclusion. So for example, had I gone with my scope from 1 through 254, and I know that my server is 192.168.0.1, I definitely do not want my server address being handed out or passed along to another computer on the network. Now, I've avoided the need for exclusions because I have strategically defined a smaller scope for my client addresses, which means that my server address 0.1 is not going to be handed out within the scope. But if I did, this is where I would exclude it. I would simply type in a range of addresses that I don't want it to hand out within the scope that I've set. But because all of the addresses in this scope are destined for client devices, I don't need to set any exclusions at this time. Let's hit next. All right, now I get a chance to set the lease duration of the addresses that I hand out to clients. Now, the default, as you can see, is 8 days. Now, by default, in most circumstances, that's probably fine. But the reason this is important to you is because it's very easy to run out of addresses if you have this lease set too high for the environment. If you're in an office environment and your computers are not changing very often and there's not a ton of turnover, these workstations are going to keep these addresses. 8 days is absolutely fine. But let's say, for example, you're providing a DHCP server that hands out client addresses in, say, a coffee shop. Well, we don't want all those addresses to be handed out for 8 full days when someone's just going to use that address for an hour and then take off, because the server will reserve that address for the entire duration of the lease. It won't hand it out to anybody else. You could end up running out of addresses in your pool. But again, just a simple test lab environment here. I'm going to leave the default at 8 days, and it now gives me a chance to add my additional configuration options. Now, remember, a computer needs more than just an IP address to participate in its networking. It needs an IP address and a subnet mask, but it also needs a default gateway. It also needs DNS servers to resolve its queries. These are the additional options that I configure right here. I can do these at a later date, and I'll show you where I can find these if I want to change them, but I'm going to hit yes, and I'm going to ask it to configure these options for me. First one, I'm challenged with what's the default gateway of my network. Now, I don't have a default gateway set up. I'm not connected to the internet. But if I did, let's presume, for example, I assign that router my default gateway 192.168.0.254. And if I hit add, it will recognize that this is the default gateway. Now, it's going to hand out this information to my DHCP client in the course of its configuration. Next, I get a chance to give it a preferred DNS server. Okay, now by default, already ready to hand out 192.168.0.1 as a DNS server. Maybe I want to have another outside source like Google or Cloudflare or something like that. I could add that right here. I'll just show you fairly simple. Let's add Google here as DNS. I'll hit 8888, hit add. It'll try to verify. It's not going to because I'm not connected to my network. But what I'm doing here is I'm adding this to the list of DNS servers that it will pass along to these clients. Now, it quite rightfully told me that it could not confirm that this was a DNS address. I'm going to hit yes because I want to show you how this will be passed along to my DHCP client. And next we go. And the next option in my wizard gives me a chance to provide an address of something called a Win server. Windows Internet Name Service. Now, this is a legacy deployment that kind of precedes our DHCP. Largely, this is replaced by our current DHCP server and DNS. If you were to be running one, this is where you'd put the address of that server. In our environment, we do not have a Win server. I can simply hit next, and it gives me a chance to finally activate this scope based on the current configurations. I'm going to hit next, and it is done. Oh, this is exciting. Now what I get to do is I get to expand this newly appeared scope. You can see the name that I gave it in the wizard, DataLAN, and you can see here that this is my address pool. As I just scroll through my options, I'm going to click through my options. The address range, the scope is 192.168.0.50 through 192.168.0.100. The next tab shows me the current leases. This is the name of the computers that have received leases in response to a DHCP query. There are currently no addresses handed out yet. And I told you I would show you where you would go to amend those scope options if you happen to forget something in the wizard, or you wanted to configure them later, or you wanted to adjust those after you had deployed your DHCP server. That option right here is under scope options. You can see that there is my router. If I right click, I can look at the properties, and you can see I can go and change or adjust if I wanted to 192.168.0.254, which I had told the DHCP server was my default gateway. You'll see also that I have DNS servers. If I right click here, go to my properties, those are the two DNS servers that I told my DHCP server to hand out to its clients. Again, I can edit and adjust right here if I wanted to. You can see there's also other available options here, and it's a bit beyond the scope of what I'm trying to do in this lab. Your DNS and router are the key ones, so all I need to do is hit OK, and we're back. Now, in the course of the wizard, I talked about these things called exclusions, how we could exclude addresses out of the address pool. There's also an option here called a reservation. So for example, maybe I wanted a computer to receive the same IP address every single time via DHCP. This is different than me statically assigning the address. Maybe I've got a client computer though that I want to hand out an address using DHCP, but I wanted to receive the same IP address every single time. I would use the reservation tab to ensure, as it says right in front of me, that the DHCP client always gets the same IP address. I'll show you how easy that is in a second. But let's verify that this thing is working. Let's move over to my client PC and challenge my server with a request for an IP address. Now, I'll show you with a little bit of a command line action here that I have statically assigned this computer 192.168.0.10. I did that to test connectivity before I started the lab. And take a quick look at the results of my ipconfig/all. You can see that it gives me a bit more information. I've statically assigned a default gateway. I've statically assigned a DNS server, all of which was me manually inputting this information into the computer. I want to change this configuration now, and I want my client PC to be addressed based on information it receives from my newly configured DHCP server. To do that, I'm going to pop into my network and internet settings, and I'm going to move into my adapter options. And here I'm going to change the properties of my IPv4 from a static IP assignment to an automatic IP address. So this is DHCP. So now you can see what's happening here. I've changed this configuration. I'm going to hit OK, and I'm going to hit OK again and close. Okay, now what's happening behind the scenes is my client is sending something called a discover request. It is sending a DHCP discover packet to its network to see if there's any servers that are on the network and ready to hand out an address. It's going to receive something called a DHCP offer from the server that hears the query. That should be the server that I just configured. It should offer an address to my client if it wants it. Now, upon receiving that DHCP offer, my client should be sending back something called a DHCP request, which will actually say, hey, thanks for this offer of this address. I would like to use it. I am formally requesting it. Now, once the server receives that response, it should return something called a DHCP acknowledgement, which will confirm to the computer that it acknowledges its request and that address is there to use. It's leased for the duration of the lease period. Now, let's see if it worked. Simplest way to check, let's move to my command line and let's do an ipconfig. Look at that. So you can see now my address was statically assigned at 192.168.0.10. I don't want that anymore. That is no longer in the scope that I want client computers to have in my network. What has happened though is my computer now has received a dynamically assigned address, 192.168.0.50. And if you remember, that's the first available address in the assigned range that I gave my DHCP server. Remember, my scope was 192.068.50 through 192.068.100, and as expected, the very first address in that scope was handed out by the server. Now, if I look even farther still, let's add the all parameter to my ipconfig, and let's see what else I can see. You can see that there's been additional information. The first thing I can see is that I now have a DHCP server who handed out this information right there. DHCP server that gave this information was 192.168.0.1. That's my server. It also handed out a default gateway. The router that my computer will use to access the internet and all other remote networks is 192.168.0.254. It found out that information thanks to my DHCP server. And look at this. Remember, I told my DHCP server to hand out two different DNS servers to its clients, 192.168.0.1 and 8888. These two addresses again came from my DHCP. And we're all set. Now let's go back to my server and refresh this a little bit. I'm going to go to my leases. Let's refresh my leases, and there you can see the lease has been assigned for the address 192.168.0.50 to PC01. The lease started just the moment it was received, and it was a DHCP lease. So if there were another computer on the network, it should receive 192.168.0.51 because that's the next assignable address in the scope. Awesome stuff. Now, I told you I'd show you how I can do a reservation. Let's say that this PC was my personal administration computer and I want to RDP to it, or I want to connect to it, or I want to talk to it, or it's connected to some service, and I don't want this address to change. In other words, I want every single time my computer turns on and grabs an address from my DHCP server, I want that address to be 192.168.0.50. I can go back to my friend, the reservations tab, and you can see here I can add a reservation. Well, I can do this a couple ways. I could right click on the reservations tab and say new reservation. I can go under my actions drop-down menu and hit new reservation. Up will come a wizard that lets me name the reservation and assign an address. But let me show you an even easier way to do this. I'm going to go to my lease and I'm going to right click on that computer that I want to add a reservation for, and I'm going to simply hit add to reservation. And you can see that I've now converted that lease into a reservation. If I pop into my reservations tab, you can see that PC01 now will always receive 192.168.0.50. That was awesome. I love successful DHCP. Hopefully it worked for you as well. Stay tuned to the next video. We're going to configure DHCP failover to build some redundancy in our world. See you soon.